Welcome to Power Electronics Education Electronic Book, Tutorial 5, Non-Isolated DC-DC Converters. This tutorial is presented by Dr. FIRUZ ZARE. In this example, we have a buck converter which should operate in continuous conduction mode, and we have to find the inductance and capacitance values. So basically the input voltage is 100 volts, switching frequency is 10 kilohertz, output voltage should be 10 volt, the ripple is approximately 1%, and the output power is between 1 up to 10 watts. So now the question is how to find the inductance and capacitance value based on the condition that the system should operate in continuous conduction mode. So first step is we know that the inductance value equals to this equation, which you can find from lecture note, dd prime times of Vin divided by 2fs switching frequency times of delta I. So basically here we know the duty cycle, because from here, from this section, we can find the maximum and minimum load resistance. So let's start with duty cycle. Duty cycle is output voltage over input voltage, which is basically 10 over 100. That means 0.1, and in this case d prime is 1 minus 0.1, which is 0.9. So now we have to find the inductance value. So in this case inductance value equals to 0.1 times of 0.9 times of 100 divided by 2 times of switching frequency, which is 10 times of 10 power 3 times of delta I, that we don't know, we have to find it. And the capacitance value here is basically equals to d prime Vin divided by 16 times of L times of switching frequency times of delta Vc. So again we know these parameters except the inductance value. So 0.1 times of 0.9 times of 100 divided by 16 times of L times of 10 power 8, because switching frequency is 10 kilohertz, times of delta Vc, which is 1%, and in this case 1% of 10 volts is 0.1 volt. So then here we have to find inductance value to be able to find the capacitance value, and here we need to find the delta I to be able to find the inductance value. But the point is that the condition that the system can operate in continuous conduction mode is d prime should be less than 2L over RTSW. So now you can think about it for 5 minutes and find how to calculate the inductance value and how to calculate the capacitance value. So in order to do that, you need to see what is the minimum and maximum load impedance, and based on that one you can satisfy this criteria, and then you can find the inductance value, then you can find the capacitance value. So now we can look at the load impedance. So output power is changing between 1 up to 10 watts. So suppose that load power is 1 watt, which is basically V out square over R. So in this case 100 over R, so we can find resistance value which is basically 100 ohms. Or if the output power is 10 watt, which is basically 100 divided by R, so here we can find resistance value should be 10 ohm. So there are minimum and maximum load impedance for these two situations. So now according to boundary condition, which is basically 2L divided by RTS W. So we know D prime, which was 0.9, which should be less than 2L divided by R. Suppose we are considering 100 ohms, and 1 over TSW is switching frequency, which is 10 power 4. So from here we can find that inductance value should be less than 0.9 divided by 200, or the inductance value should be less than, for this case, 4.5 millihenry. So this is the condition for this resistive load. So this is for R equals 100 ohms. So we can also find the inductance value, the minimum, for this resistance value 10 ohm, which is basically 0.45 millihenry. So the case is that this is the answer, because definitely if the inductance value is 4.5 millihenry, that can satisfy this condition as well. So now we can find the other parameters, which is basically delta IL and capacitance value. So basically delta I, according to current waveform, when the system basically operates at the boundary condition between continuous and discontinuous mode. So that means if this is the inductor current, which is basically load current, the DC part, and this is delta I. So in this case delta I can be either calculated from the equation directly, or should be equal to the load current, which is 10 volts over 100 ohms, or 0.1 amp. So when the load current is maximum, which is basically 10 volts over 10 ohm, this is load current for R equal 10 ohms, which is 1 amp. So here we can see that the ripple is less than load current. That means for this condition the system operates in continuous conduction mode. And for the capacitance value, we can find the capacitance value according to the equation, which is basically 12.5 microfarad. In this example we have to find the output voltage when the duty cycle is 0.1 and 0.9 for these parameters. So the first step is to know whether the system can operate in continuous conduction mode or discontinuous conduction mode. So this is the condition, which is basically D times of 1 minus D square should be less than 2L divided by R times of switching frequency. So let's start with the first duty cycle. That means 0.1 times of 1 minus 0.1 square should be less than 2 times of 0.1 millihenry times of 5 kilohertz divided by R, which is basically 100. So now we can simplify that one, which is 0.01, and this term is 0.1 times of 0.9 square should be less than 0.01, or here we can see that 0.081 should be less than 0.01, which is not correct. So that means the system is operating in discontinuous conduction mode. Now we need to find the conversion ratio. So the case is that, what about the other one? The other one means that the second duty cycle. So in this case, because 0.9 times of 0.1 square should be less than 0.01, here we can see that 0.009 is less than 0.01. So that's correct. That means the system can operate in continuous conduction mode. So we can find the output voltage for that case. V out over V in is based on 1 over d prime, or 1 minus d. So we can find the output voltage, but for this case, this continuous conduction mode, we have to find. So think about it. According to the lecture note, you can find the equation and you can find the conversion ratio. So what is the output voltage? So the output voltage is 12 divided by 0.1, or 120 volts, when the duty cycle is 0.9. But for the other one, the output voltage according to the lecture note is V in times of 1 plus root of 1 plus 2 R d square tsw divided by L divided by 2. And when we put these parameters, we get 12 volts times of 1 plus 1 plus, so resistance value is 100 ohms, 2 times of 100 times of duty cycle is 0.1, which is 0.01 when we calculate the square of that one. So divided by L, which is basically 0.1 millihenry, times of switching frequency, which is 5 kilohertz, over 2. So when we simplify this term, so approximately 12 times of 1.6, which is 19.41 volt. So next section is to find the resistance value to ensure that the system always operates in continuous conduction mode. So according to the lecture note, this is the condition when we have continuous conduction mode, which is 2L times of switching frequency divided by R. So in this case, 2 times of 0.1 millihenry times of switching frequency, which is 5 kilohertz, divided by R. So here we can find that R should be less than 6.75 ohms. So in this case, the system always operates in continuous conduction mode.